Alright, today we're going to learn about abstracting procedures, which basically means that we can actually send around procedures as arguments and have the functions return them as values. And you'll understand later what I'm talking about. Alright, so now let's just start out defining a function called list_add1 that takes a list like 1, 45, 8, and it will add 1 to every element in the list and return a list of that. So this would be 2, 46, and 9. Alright, now this is pretty simple for us. After some other things that you've already done, this should be fairly easy. So we'll just take a list. Alright, if null ls, then we'll return empty list, otherwise we'll cons car of ls plus 1 onto the list add the CUDA of ls. Alright, let's run that, make sure it works. Oops. Run list add 1, 1, 4, 6. We should get 2, 5, and 7. Alright, that's good. Now let's say we want a function called list square root, and of course if you remember, you do square roots like this. Alright, we can just basically take this. It's going to do the same thing as list add, but it's going to do the square root of every element in the list. And this is a flat list, by the way, not one with multiple levels. Alright, so basically all we have to do is change this from +1 to square root, so we can copy and paste this. Oops. List square root, get rid of that and call list square root instead. Run it. Let's try this. List square root 1, 4, 16, 25, and there we get 1, 2, 4, 5. Those are the square roots. Alright, let's try list times 10. Now we'll get crazy and say list times 12. Alright, so we can basically copy this whole thing again and just multiply it by 12. Alright, then we'll call list times 12. Right, then run this. List 12, 1, 2, 3, 4. There we get those things all times 12. Okay, so do you notice any similarities between these functions? I mean, there's obviously quite a lot of similarities because, let me just change that, because we just copied and pasted, and so in each one of these we are we're going down the list. We stop when it's null and rebuild the list, and then we just mutate one particular element in the list, and then we call the same function on the CUDA of that list. Now actually there's a scheme procedure called map which sort of abstracts this. Wouldn't it be nice if we had a procedure where we could give it a list and then we just gave it whatever we wanted it to do? Like we could give it square root and it would do square root on all those things. And that's actually called map. Alright, and it's built into scheme actually. So first you do the function that you want, so square root in this case we'll say, and we could do 2, 4, what is it, 16, oops, square root of 2, oh yeah, the square root of 2 is 1.142 ... Yeah, I'm right. Alright, so map will just go through each one of these things. So let's define map ourselves. Yeah. Oh, first let me show you one more time that. Okay, so let's say we wanted to do the add one thing. And let's say we don't have a function named add one, so we'll have to put that in ourselves. Lambda n plus 1n. And then we'll apply that to this list here, which is like 1, 2, 3, 5, let's say. Alright, so what's going on here? This is just a function, it's a procedure, and map takes a procedure as an argument, just like square root was a procedure. Square root was really mapped to a lambda, to a procedure lambda here. So we just created one on the fly. Lambda, it takes one argument, n, sort of like square root just takes one argument. So it'll go down first, it'll take 1, it'll add 1 to 1, put it back, and it'll be 2, and then this will change to 3, that'll be 4, that'll be 6. Alright, so let's define our own version of map, and we'll call it something else, like map2. Now we'll call it iMap, sort of like the iMac and iPhone and iPod and whatever else you want to call it. Alright, so define iMap. Lambda proc, which stands for procedure, of course, and then the list. So what we want to do, we can basically look at this. So when the list is null, we want to return the empty list. Alright, then we want to cons, and we want to do something to the car of ls. In this one we multiplied by 12, because that's what, this one we did the square root, and this one we added 1. And this one we want to apply procedure to the car of ls, so we can just run it like this. Procedure to the car of ls. Alright, we want to cons that into, what is this? We want to cons it into the recursive call of the function with the CUDA of ls. So into the iMap of the CUDA of ls. Right, let's run this, see if it works. iMap plus plus square root 1, 2, 5. Well, none of those actually have good square roots except for 1, so it's going to be alright, so let's see. Procedure iMap expects 2 arguments given 1. So if you didn't catch that before, sorry that you couldn't have stopped me, since this is a video, you might have caught it. Alright, so we need to, when we're calling iMap, it takes a procedure and a list, and we're just giving it a list, so we have to give it the procedure again here. Alright, now let's run this. iMap square root 1, 4, 9, 16. 1, 2, 3, 4. Alright, iMap, to do iMap times 12. N times 12n 1, 2, 3, 4. Alright, and that's what we'd expect, but the iMap, the proc in here, it only takes 1 argument. See, we're running just 1 argument on it, so if we give it something that takes 2 arguments, well, we'll just make one up, lambda a, b, and we'll just add them together. When we try to run this here, it's going to give us an error. Alright, see, it expects 2 arguments but given 1. Alright, so let's do, you can do more than just arithmetic, of course. Let's do a function using map that that will wrap every element in a list in parentheses. So like A, B, C will be A, B, C. Alright, so let's try that real quick. iMap, lambda A, cons A into an empty list, and that's it. A, B, C. There we go. Now if we wanted to define that as a function, we could say define wrap list lambda ls map, and then we just paste this into there, map that onto ls, then we wrap list ABC, and you've got it. So that's map.